Okay, everybody, thank you so much for tuning in, and I'm excited that you are here for our final webinar for 2020, and for y'all hanging in there with us. Thank you for your cooperation through COVID, and thank you for trusting the leadership of your Master Gardener Coordinator, and want to encourage you to keep learning and reading and keeping in touch with each other as much as possible during these times. And I wanted to let you know that the State Master Gardener Volunteer Program is changing addresses. If you didn't know, we are going to be on East Campus, and we are going to be about maybe 3 or 4 miles away from main campus, which is great because it will be easier for you to find us. So we're right off of Waldo Road between 16th and 23rd, and there's plenty of parking. We've got some great meeting space here. So hopefully when we can all get together again, we will see each other face to face in my new space. So if you didn't know, my name is Wendy Wilbur. I'm the State Master Gardener Coordinator, and we are programming our webinars today to provide continuing education for you on great topics that pertaining to gardening and horticulture in Florida. And to that end, we have provided 12 different webinars in 2020. And our last but not least is Dr. Lisa Krimsky. She is a water resource RSA. We call those regional specialized agents. We have 5 of those regional water agents in Florida, and her efforts are focused mostly along the Indian River Lagoon Estuary, and she is has been with IFAS for over 12 years. So she's not a newcomer, and many of you know her well, especially in the South region of Florida. And she went to the University of Maryland and received her PhD from the University of Delaware. And her focus areas are protecting water, enhancing water quality, water conservation, water in the built environment, and water as it pertains to natural resources in Florida. And Lisa has a pretty active blog life, and her most recent blog is there on the bottom about fish kills in northern Indian River Lagoon. So if you're looking for more information, Lisa is a great blogger, is always well written and well thought out. So those are definitely worth checking out. All right, well, welcome, Lisa. I'm going to go ahead and stop sharing now, and so you can share your screen, and welcome to the Master Gardener Volunteer webinar.
Hello, everyone, and I don't think I'm sharing the right thing. So let me stop and try it again. Are you seeing the presentation?
I am.
Oh, really? I don't have my fancy green box. Okay, I'm going to continue and stop if you tell me it's wrong. So thank you for the invitation to speak today. My focus area is on water, and it's shifted quite readily to coastal water quality and harmful algal blooms. And while my regional intent was supposed to be the Indian River Lagoon, as really one of the few extension agents in the state who focus on harmful algal blooms, I've really taken on sort of a statewide perspective on this issue. So I'm excited to be able to talk with you all from the entire state. It's really exciting for me. So I'm going to focus on algae blooms today, and especially at the end of the presentation, kind of shift about how this pertains to you as master gardeners. And Wendy gave me a bit of a directive to provide an overview, but really also to provide responses or answers to some of the most frequently asked questions that I get, so that you as volunteers on behalf of UF-IFAS can also help respond to these questions and maybe be more knowledgeable yourself. So I'm going to begin. Okay, just to confirm with the thumbs up, Wendy, you are now seeing the next screen, a big green. Okay, perfect. So I have to start this presentation. You're talking about algae blooms. I have to start a presentation on what are algae, because this sort of provides the foundation for everything. Algae are a diverse group of photosynthetic organisms. They are primarily aquatic, which means that they can be found in fresh, brackish, or marine waters, but they can actually be found on land too. And they are, again, extraordinarily diverse, meaning that they can be microscopic, as you see in that top left picture, or they can be very large. So the kelp forests that we often see those ubiquitous pictures of off the coast of California and the west coast of the United States, those are also technically algae. The pictures depicted here are some of Florida's species of algae. So we've got the red tide on the top right corner. We have one type of macroalgae, the red drift algae, and then we have sargassum on that bottom left. Now we also have cyanobacteria, which bloom and kind of fall under this larger umbrella term of algae blooms. But it's really important to note, and I normally don't show this picture because it's, it's getting a little technical, but seeing as you are all master gardeners and you understand and appreciate plants, it's important to note that evolutionarily speaking, cyanobacteria and plants, including the algae, are really far apart in terms of where they lie. So cyanobacteria are not plants at all. They are in fact photosynthetic bacteria. And for those of you who like trivia, it's thought that cyanobacteria were actually the first photosynthesizers on the planet. They are actually responsible for creating an oxygen dominant atmosphere and are responsible for about 50% of the oxygen that we breathe. And it's thought that today's plants evolved from cyanobacteria. So it's a little bit of trivia for you. They're extremely old and they are ecologically essential. So life as we know it on this planet wouldn't exist without cyanobacteria. They, again, as I mentioned, they're responsible for the oxygen in our atmosphere. Plants, as we know it today, they fix nitrogen. They are the primary level of the food web, and the ocean and the aquatic food web as we know it is the foundation are cyanobacteria. So we can thank them from everything from our fish, our crabs, our crustaceans to the whales. And they also, being plants and using carbon dioxide for photosynthesis, they are essential for carbon sequestration on our planet. So just in general, to kind of recap, algae, including the cyanobacteria, I'm going to kind of use them interchangeably for here on out. They are ecologically essential. We need them. And even though we often refer to them in a negative way, most algae and cyanobacteria are extraordinarily helpful to us. So try and keep that in the context as we move and talking about the negatives of these organisms. So when we talk about algae, we tend to classify them in 5 main themes, 6 if we include the cyanobacteria. And it's related to color. This gets extremely confusing because they have different photopigments. The pigmentation can change. And so that common name classification that is referred to primarily by color isn't always what we see when we're actually looking at the organism or what we refer to them colloquially. So I don't want you to get sort of caught up in all of the different species that we have and the common names, but I think it's really important to note why it's really important to speak accurately and sometimes use scientific names when you're talking about these algae blooms and harmful algae, because by referring to them just casually in a common name, we could be confusing people and potentially portraying inaccurate information. So just for example, we call cyanobacteria, sort of a common name is blue-green algae. It's totally different from the common group green algae. Sargassum, that picture that I showed you of that macroalgae that often is washed up on the beaches, it's a type of brown algae, and yet we call them golden tides. Go figure. Karenia brevis, we call it red tide. It's not a red algae at all. It's actually a dinoflagellate. So, and I can go on and on. Oreorumbra lagunensis, which we have here in the Indian River Lagoon, we refer to that as a brown tide because it changes the water color brown. Again, not a brown algae. It's a picoplankton. So I don't want you to get sort of caught up in the details of this, other than, again, just to reiterate that we need to be really accurate when we're talking about these things to prevent confusion and possible mismanagement. So, you know what algae are, including the cyanobacteria. What are algal blooms? So an algal bloom is the rapid and substantial increase in biomass in an aquatic system. Not all algal blooms are harmful. So a harmful algal bloom is differentiated in that the species itself either produces toxins or it can have harmful effects on human health and aquatic ecosystems. So for example, again, going back to that sargassum, that large macroalgae that we see sometimes on the surface in the waves at the beach or washed up on the shore, in really large concentrations, while it's not a toxic species at all, in large concentrations, it can result in low dissolved oxygen, which could end up in issues for the benthos or some of the fish, causing low oxygen related stressors. What's also important is, and again, this is kind of what I was getting at with that previous slide, is that not all blooms are the same. So you have thousands of different types of algae species. About 1% of those are toxic. Of those, they're all very different, which means that you have to manage them differently. What causes them may be different. The different control mechanisms also may differ. And just because you have a bloom of a harmful toxin species, it doesn't mean that the toxin may actually be present. And this is oftentimes the case with cyanobacteria, those blue-green algae blooms. Just because you're having a bloom doesn't necessarily mean that toxins are present. So it's a complicated story that we have here. So algae and cyanobacteria need primarily 3 things in order to exist. And you guys all should know this. It's pretty essential basics if you're thinking about photosynthesis. So you need sunlight, you need nutrients. And when you're talking about aquatic systems, those are external to the water body. So those that may flow in through surface water runoff, or stormwater contribution, or even atmospheric deposition. When it rains, there's nitrate in that rainwater, as well as internal nutrients. So those that already exist, either naturally or unnaturally, in the water body itself. So you have 2 sources of nutrients. And then the third thing we sometimes don't really think about, and that's time. So there is a reason why stormwater ponds and canals tend to have, and even your swimming pool, if you don't clean it well enough, tend to see algae blooms more frequently than large flowing rivers. It's because the water is fairly stagnant. If you have fast flowing water, it can sometimes flush out that algae and doesn't allow that large biomass accumulation to occur. This is really a unique situation. If this happens in the St. Johns River up in North Florida, where in faster flowing regions of the St. Johns, you won't see cyanobacteria blooms, and in slower, shallower regions, you do. So it's kind of this start-stop regional. So what causes algal blooms? And again, keeping in mind that there are a lot of different algae out there, there are some general factors that can influence the occurrence of an algal bloom. These, of course, include nutrients, which we just talked about. Water clarity. So they are photosynthetic, whether you're talking about cyanobacteria or algae, and they need light. So if you have a lot of shading, if you have a lot of cloudy days, the intensity of a bloom is going to decrease. Circulation patterns and hydrology, again, going back to that time, that fast moving water or slow water. Climate and weather, this is especially true. Climate, when you're talking about cyanobacteria, they like it hot. Cyanobacteria like warm temperatures. And so while they are found in cold areas, in fact, they're actually cyanobacteria that live in the snow, they do prefer warm weather. And weather patterns, when it rains, it also brings a lot of that surface water runoff, and with that is nutrients. So that can also influence when or if we see an algal bloom. And then biological community interactions. And that's just a really fancy way of saying, is there something in that aquatic system that's going to eat this algae? And if there is, then that might be a natural way to keep that population more stable. And it's also important to note that harmful algal blooms don't necessarily mean that there is an overabundance of nutrients or that there is a human-caused source of nutrients. So some of the areas that exhibit some of the worst algal blooms, like off the coast of Alaska or in Patagonia, are some of the most remote places that aren't inhabited by humans. Some harmful algal blooms are just natural. That being said, even those natural blooms can be exacerbated by human sources of nutrients. And that's the case that we see with the Florida red tide that we have in the Gulf of Mexico. It's a natural bloom. It's been here before we had, a large population of Floridians in the area. It's gonna exist no matter what, but it can be exacerbated, especially when it comes to the nearshore environment because of the sources of nutrients that we contribute to the water body. So this is a map to show the global distribution of HAB events. I don't want you to get too caught up into the numbers here. Basically, what I want you to show you is that there are HABs, harmful algal blooms, everywhere on the globe. The differences in numbers really is probably more an account of the monitoring programs and the reporting of HAB events than the actual sheer number of events itself, which is why we see a really low number in Africa and South America. It's more of a response to the actual existing monitoring programs there rather than the number of harmful algal blooms. But this is just to see that they're global. So other than, the definitions, this is our first frequently asked question. And I get this all the time. Are algal blooms really getting worse? And the answer is yes. Here's a map showing from pre-1972 to current state on the top. You can see the distribution of marine harmful algal blooms in the United States, and they are absolutely getting worse. So what are the reasons for that? And this is not just in the United States, by the way. Globally, they are increasing in frequency. Well, the first is climate change. Again, many harmful algal bloom species, especially the cyanobacteria, like warm waters. With climate change, we're getting warmer temperatures, including waters, which are more likely to support the increased growth of these species. And we're getting more severe weather, which means more rain, which means that the ground gets saturated. It can't handle that large amount of capacity of water at any point in time. So rather than infiltrating our ground and ending up into the groundwater and our aquifer, it's running off and bringing with it those excess sources of nutrients. We also have human introduced nutrients, of which we're all probably intimately familiar with. And that is a contributor. As population increases, so does our sources of nutrients, which is food and fuel for these algae. But again, referring back to that previous slide, we also have better and more monitoring. So we're just detecting these more than we ever were before. So while we are seeing increases, our detection and our ability to respond to these blooms is also increasing, which is some of the reason why we're seeing increases in numbers. But here's another way to picture this. This is a really cool interactive, well, it would be interactive if you went to the website, a graph that shows it's the reports of algae bloom in the news media from just over 10 years. And you can see that the annual number of news reports in, I believe this is the United States, was below 100 in 2010 and over 500 in 2019. So while this isn't necessarily an indication of an exact indication of the number of algae blooms, you can see that journalists tend to report and respond to big events. And so this would be sort of a causal relationship of the number of media reports increasing as the number of harmful algal blooms also increase. Okay, so we're going to shift the focus a little bit to Florida. And this is a map when you're talking about, again, just to show kind of where Florida lies in the national setting in terms of harmful algal blooms. This is a map that the National HAB Office produces. And it's important to note a couple things. First, all 50 states, no matter where you are, they have harmful algal blooms, especially cyanobacteria blooms. They tend to report HABs based off of, and the marine HABs based off of the syndrome associated with shellfish. So marine HABs mostly get accumulated in shellfish and impact humans in that way. So you can see all these lovely terminology: neurotoxic shellfish poisoning, paralytic shellfish poisoning, amnesiac shellfish poisonings. They're pretty terrifying. And that's because shellfish consumption is the primary route for marine harmful algal blooms. Not the case for cyanobacteria, because cyanobacteria are freshwater primarily, and there aren't that many freshwater shellfish. So for cyanobacteria, the primary modes of human interaction is through recreation, swimming or boating on a waterway, through aerosolization, so just breathing in toxins in the air if it's an aerosolized toxin. That's also the case for our Krimsky brevis red tide, which has a neurotoxic shellfish poisoning. And in drinking water. But in Florida, we're lucky most of our drinking water does not come from surface waters, so they're not going to be impacted by harmful algal blooms. So that is a benefit to the state of Florida, is that we don't have to worry about cyanobacteria blooms primarily in our drinking water. But if you're taking a look at this map, there are a lot of multicolored dots on it. So we have a lot of different types of marine-related HABs, as well as those freshwater cyanobacteria. This is another way of looking at it. This is my hand-drawn, non-comprehensive map of HABs in Florida, but I think it gives a good overview, basically showing that if there is a waterway in the state of Florida, albeit fresh or marine or brackish, is likely going to have a harmful algal bloom. So the biggies are that red one across the entire Gulf of Mexico. That's Krimsky brevis red tide. The purple one that goes across the entire state, that's Pseudonychia. Primarily, although it does have toxins, we rarely have closures. The only time we ever had closures, you can see that little circle in the panhandle. We've had shellfish closures, I think 2 or 3 times ever because of this sky in just that one region in the state. Then we have the cyanobacteria blooms, of which we have many, and they impact most of our fresh waters. Indian River Lagoon is unique in that it's got a bunch of special guys. It's got brown tide, it's got pyridinium, which is that really beautiful bioluminescent algae. And actually this year, for the first time, it has a cyanobacteria bloom, which is, again, unique. Down in South Florida, we have that sargassum and diatoms. So we have a lot. They're geographically distinct. Their toxins are distinct. And again, I think that's important for a management perspective. So why do we have so many HABs in Florida? Frequently asked question number 2. First, we have a lot of water. These are aquatic algae and aquatic cyanobacteria. And here in Florida, we have a lot of water, fresh and marine. So our fresh water, our total water covers more than 43,000 miles. We've got thousands of miles of rivers, streams, and waterways. We have the second largest coastline in the United States, more than 7,000 lakes, and more than 70,000 stormwater ponds. All of those water bodies, natural or not man-made, are capable of having an algae bloom. We also have shifted our land use pretty significantly. And I know this is kind of a blurry map, but we went from having fairly natural environment, which would allow for surface infiltration, for natural replenishment, less human sources of nutrients, to one that is urban dominated as well as agricultural dominated, both of which have additions of nutrients, both of which minimize the amount of natural infiltration. We also have a much larger population, and it's continuing to grow. We all hear that number of, how many people are moving to Florida on a daily basis, and it's pretty staggering. And people are a nutrient source. And I'm not just talking about the external nutrients that we apply, but the internal nutrients that we deposit every day. And so in alphabetical order, here's just a list of all of the nutrients, or maybe not all of the nutrients, but the primary nutrients that we have here in Florida that contribute to our algae blooms. And algae blooms can be, depending on the water body, the limiting nutrient can be either nitrogen or phosphorus. So managing both of them is really important. And so atmospheric deposition, fertilizer, both in the ag and urban environment, that changing in land use and runoff, industrial effluents, animal waste, municipal wastewater, reclaimed water, septic systems, and stormwater. And so why do we care? Because there are a slew of impacts. And you can kind of pick any one of these as to which is most important to you, but they are vast and they are great, and you cannot minimize them. Whether they're environmental impacts, the economic impacts, or now we're even recognizing the mental health impacts associated with chronic blooms in some of these areas. So who's responsible for managing the HABs, and where do I go for information? There is a slew of agencies, both at the federal, state, and local level that are responsible for HABs. In the state of Florida, marine HABs is managed by Florida Fish and Wildlife Conservation Commission, and they actually have a research MOU with Mote Marine Lab there on the left. Freshwater HABs, so mostly the cyanobacteria blooms, are managed by Department of Environmental Protection. So they have both a routine monitoring program, and then they will also respond to, if you notice an algae bloom and you report it, they'll respond to those as well. And they go out and they collect the samples and test for what species it is, as well as test for toxins. And then the Florida Department of Health takes that data and then is responsible for the public health notification of that. So they are the three core members. But remember, I also said that for marine HABs, one of the primary modes of human interaction is through shellfish consumption. And that's where FDACS, the Florida Department of Agriculture and Consumer Services, comes into play. They have an extraordinarily robust shellfish monitoring program to prevent shellfish illness associated with these algae blooms, and it's successful. They have close to zero reported illnesses associated with shellfish consumption and absolutely zero deaths associated with the consumption of it in Florida because of this really robust monitoring program. We also have NOAA at the national level. And I've given you the websites, the primary websites for you, just in case you want to look at more information. But it's important to note that the state of Florida is recognizing that it's kind of confusing for residents to have to go to and navigate to 3 different agencies to find information. So they're working on it, a coordinated effort to create sort of this unified water quality location. It's called protectingfloridatogether.gov. This is kind of a snapshot of what it looks like, and you can go out and you can see where they're actively collecting water samples, and then the status of those algae samples, as well as sort of what they found, was it toxic, what species, and probably more information than you would ever want to know. So how do we manage for this? Well, keeping in mind that in order to get support for harmful algal bloom management, you also have to have public support. So what does the public think about this? Well, again, when you look back at that equation of what causes algae blooms, you have sunlight. We really can't do a whole lot to manage that. We have time, and for certain water bodies, you can make some hydraulic manipulations that may have some significant impacts. In fact, they're actually looking at that with Lake Okeechobee right now in their discharge schedule. But the primary piece of that equation that we as individuals and as humans have something that we can tweak is the nutrient side of it, especially those external nutrients. So frequently asked question, I think we're up to number 4, is what can we do? How can we make improvements in this really challenging issue? So there are 3 main strategies that we have. We have prevention, which are essentially those actions that attempt to address the problem before they've begun. You have mitigation. So, okay, we have a bloom. What can we do to minimize those harmful effects? And then control. So that's actions that manage the bloom after the bloom has occurred by reducing the actual duration and extent of the bloom. So on top, prevention, that's a treatment wetland area for managing some of the major discharge areas and trying cleaning it before it gets discharged out. Mitigation, this is a reporting system so that residents and visitors can go and see where red tide is and make those informed decisions for themselves to decide where they want to be recreating away from the harmful algal bloom. And then control, this is the application of copper on what looks to be a small lake, which would actively kill the harmful algal bloom itself. So we did a survey of IFAS Extension Advisory Committee members last year on their perceptions of harmful algal blooms. So some of you, if you're a member of an Extension Advisory Committee member, you might have actually taken this survey, in which case I want to say thank you. And we recognize that our advisory committee members are kind of a really unique segment of the population, and they're not necessarily representative of the state of Florida and its residents as a whole, but it's still an extraordinarily important group because you all are the ones who are actually going to go out and likely make changes and make decisions and be part of the solution, because by your nature of being volunteers, you're an engaged citizenry. And so we asked them, of those 3 measures, what is your primary? And by far and away, prevention. 76% of individuals said that they preferred prevention. So essentially stopping blooms before they start, which means really addressing that nutrient problem. Which means we have to change behavior. And that's what we do here in Extension. And hopefully that's what you all are familiar with as volunteers through your participation in the Master Gardener Volunteer Program. And when you're looking to change behavior, there are a couple things that you need to keep in mind. And again, I want to frame this in the aspect is that right now we're talking about changing behavior of Floridians as sort of general. We really try not to talk about the public as an audience, but I want you to think of the public as being individuals who are not like you. By the fact that you are a master gardener and a volunteer, you are not the general public. You are above and beyond committed. You really care. You're taking your precious time to learn about something and to do something about it. Most of the general public is not like you. So as we talk about sort of this next section, I want you to keep that in mind. Don't think about yourself. Maybe think about your neighbor or your cousin or, I don't know, your teacher who's, you know, your kid's teacher who's trying to figure out just how to use Zoom. So when we're talking about behavior change, there's a couple things that we want to keep in mind. People have to care about the problem. So in this case, they have to care about harmful algal blooms. They need to have ownership in that problem and think that they can actively make a difference. There needs to have a sense of knowledge about it, but not knowledge in the sense of a transfer of science-based information, which is always important in what we strive to do here in Extension, but also recognizing that perceptions and values, although they might not be science-based, they are just as important, and we can't discount that. So sometimes we have to talk to individuals and we are never going to change their mind, no matter how much science or fact we throw at them. But that doesn't mean that we should be discounting their values. And by just the nature of having them change their behavior, we're asking them to change what they normally do, change the status quo. And so we have to make that a positive experience for them, meaning that the benefits of that change have to outweigh the barriers. So I'm going to go over this a little bit. This is results from that survey again that I'm talking about. So, do people care about water quality and harmful algal blooms? In our survey, as well as numerous other surveys of Floridians, show that yes, water quality continues to be ranked as the most important environmental issue in Florida today. So that is score one. People care about water quality. For whatever reason, it doesn't really matter. They care, which means that they are more likely to be part of that solution. The next thing is ownership. Do they feel like they can be part of that solution? Do they feel like that if they make a change in behavior, they go out of their way to change their status quo, it's going to make a difference? And again, our survey illustrates that yes, they really do believe that Floridians at every level have a role to play in managing and protecting Florida's water quality, and that what we do can influence it. So whether it's Floridians as a state, whether it's local neighborhood or individuals, we feel that we can make a difference, which again is really encouraging. So we have that ownership button. Knowledge. So we asked people, I gave you that long list of, maybe a dozen contributors of nutrients here in Florida. We presented them with a slightly smaller list, but we said, what do you believe to be the largest contributor of pollution in Florida's water bodies? And this is where I have that caveat of sometimes perception is just as important as, actual scientific knowledge. Our own Extension Advisory Committee members think that residential and urban fertilizer use is one of the primary contributors of pollution to Florida's water bodies. For some of our water bodies, that may or may not be the case. It doesn't matter because we need to address all nutrients. And if they believe that residential and urban fertilizer use is a primary source, then that means that we can tweak that cog, and that is a place where we can actually make a difference. Whether it is the primary source or just one of many contributing sources, this is a place where it doesn't really matter, because by addressing it, we're still going to be reducing the overall nutrients. And then the last thing is benefits and behaviors. So why do people care, and can we improve, make it more palatable for individuals to change their behavior? Well, when you're talking about water quality for at least this group of Floridians, the impacts on wildlife and fish, as well as the impacts on public health, are the primary motivators. So we need to communicate about improvements and ways that we can reduce our impact in light of these two factors, and maybe not focus so much on economic impacts, which I think is where a lot of people automatically go, is, oh, it's costing us millions of dollars in, tourism related money by these harmful algal blooms and people not coming. It doesn't necessarily resonate with everyone, and that might not be that primary motivating factor. But if we can say, there's a serious human health impact associated with this, and we owe it to ourselves to solve the problem, that might be sort of that educational communication that we need in order to strike that motivation to change behaviors. So this is the only sort of data I'm showing you today. And I actually don't even really want you to get focused in on the numbers. This is a project that we did looking at sources of nutrients in urban landscapes, and just where are these nutrients actually coming from? This study was done in Brevard County, and we compared dry season and wet season. And all I want you to note is that in residential yards and landscapes, because again, focusing, you all are master gardeners, and fertilizers were ranked #1. This is where we're focusing. Atmospheric deposition was about, almost a third of the contributing sources of nitrate. We can't do anything about that. So let's just kind of ignore that. What are our other sources of nutrients? We had a small source of nutrients and nitrates that actually are coming from pets and pet waste. The FFL program doesn't address that. Let's kind of ignore this. We had a significant amount of nutrients coming from applied fertilizers. We know this, the data backs it up. So that's one source on our urban landscapes that we can do something about. The other source is actual soils. Soils hold on to and are sort of residual legacies of nutrients. And this is why you all promote soil testing before fertilizer application occurs. So that's something that we can do something about, and something that's part of the FFL program, as well as organic sources of nitrogen. So that's our grass clippings, our leaf litter. Those are also sources of nutrients that we can do something about. So when we're talking about nutrients in the landscape and the FFL program, these are your 9 principles. You all know these. You're probably much more intimately familiar with them than I am. So I even hesitate to share this with you. But when you're talking about FFL and you're talking about nutrients, there are a few ways to reduce them. You can actually reduce the application of nutrients in general, whatever form that may be, or you can reduce the transport of those nutrients. And you have many of your 9 principles that address some component of these. Not all of them, but most of them address some component. Now, here's the thing. You have 9 principles, and within each of those principles, you've got a lot of different choices or behaviors that individuals can make. So you're talking about, let's just assume each of the individual principles has 4 to 5 behaviors that an individual can make based off of that principle alone. That's 45 behaviors we are presenting to the general public. Most people can't handle more than 2 or 3. They're like, brain explodes. There's like, There's a reason why the Master Gardener program is over an extended period of time. It's a lot of information. It's a lot to take in. When we're talking about the general public and sort of this one-stop high impact program, we can't present them with 45 different things. We need to identify those 1 or 2 behavior changes that are part of the FFL program that can make significant impact, either by reducing actual nutrients themselves or reducing the transport of those nutrients to our downstream water bodies. So this is my challenge for you all and my opportunity to learn from you, because as I don't know how many of you heard the introduction, I am not a horticulturalist. I cannot grow a darn thing. But you all can, and you do, and you know urban landscapes really well. You volunteer, you work with the public, and you're intimately familiar with the 9 principles. So I am going to ask you to either open up another tab on your computer, go to this website, www.menti.com, and enter the code in the bar that shows up. Don't worry about spaces or anything, just enter those 7 numbers. Or you can take your iPhone, turn on your camera, and just put it right up against your screen. And your phone, if it's clever, will say, oh, we've detected a QR code. And you just say, click, accept. So those are the 2 ways to, to do it. I'm going to leave this up there for a few seconds. I've got 1:44 on my clock. I'll wait till 1:45 to make sure you've all got time to get the code and figure it out. Oh, people are already participating. All right. Okay, I'm going to assume, because I've got a lot of people already participating, that you guys are figuring it out. So I'm going to swap screens right now, if you can. Okay, so if you haven't already done so, I want you to tell me, what is the one nutrient management, could be either nutrient reduction or nutrient transport action, that you think residents are most likely to adopt? I don't want you to tell me the principle. I don't want you to say fertilize appropriately. I want you to get specific. And this is the opportunity for you to help me inform my extension programming and really focus on what one or two behavior changes that if we as Floridians make can really be impactful. So hopefully you're all seeing this scroll by. And hopefully this can help us in extension really prioritize where our efforts should go when we're talking about water quality and harmful algal bloom management at the residential landscape level. So I've got 31 people, I think 31 people are participating. And the more specific you can be, the more helpful it will be. And I promise I will compile all this and I'll share this with you, Wendy. All right, so we have soil testing, fertilizer control, follow the fertilizer ordinance, reduce the use of fertilizers. So I'm sensing a trend here. Fertilize appropriately. Water the lawn less. Okay, so we got someone who went to the nutrient transport side of things. Do a better job with fertilizer usage and fertilize carefully. Pick up fertilizer that gets on impervious surfaces. Soil testing again. Okay, great. I'm going to give you guys maybe 1 or 2 more minutes to finish entering in your thoughts, at which point we'll wrap it up. Reduce fertilizer. Most won't stop. It's like a drug. More. Seeking out education on how to save money when using fertilizer. Irrigation, again, a nutrient transport. Check for overuse. Okay, fantastic. So this is going to stay open. I'm going to switch back to the presentation, but this is going to stay open. So keep entering in your thoughts while we move forward. Okay, so you all should be seeing the presentation again if I did this correctly. No? Helps if I click share. Okay. So I threw a lot of information at you today. I recognize that. I think the takeaway is that harmful algal bloom dynamics are extremely complex. We have a lot of water in the state of Florida, and we have a lot of harmful algal blooms. And algae species, development, growth, termination, it's not a one size fits all. And so we can't expect to control and manage them as a one size fits all. But what is the same of all of them is the preventative measure, which is reducing our human sources of nutrient inputs. And so you all are helping to identify ways to do that. So I want to encourage you and thank you for already being part of the solution and making informed decisions. Just by being Master Gardener volunteers, you're already part of the solution by helping us to educate others. And with that, I will take any questions.
Oh, we have lots of questions. I think that the Mentomere exercise was a huge success. I'm really glad that everybody jumped onto that. And so that's great. First, let me compliment you. 3 or 4 Master Gardeners have typed into the chat box what a great presentation this is and how wonderful the information is and what a fantastic presenter you are. So you get a nice early Christmas present from us. So that's nice. Okay, so we have, like I said, quite a lot of questions that we're going to jump into. And the first one is from Martha Williams. The saltwater HAB syndromes are only from fish and shellfish consumption and not recreation?
So the actual consumption, the syndromes that I showed you are just shellfish related toxins. So it's not even fish. Most of the fish species show that the toxins don't accumulate in the muscle of the fish, which is what we as humans consume. So as long as you don't eat the guts, fish are safe. It's the shellfish. So our oysters, our clams, mussels in those areas where they have mussels, where the toxins accumulate. And the problem is that it doesn't really tend to kill the shellfish. So they just continue to survive while accumulating the toxins, but it transfers to us upon consumption. The reason why we don't have a whole lot of illness in Florida, again, is because of that really robust monitoring program. The only few illnesses that we have associated with the shellfish is from recreational harvesters. Okay. So it's really important that if you are going to go out and recreationally harvest shellfish on your own, which is a fantastic activity, scallop season is a huge thing here in Florida, just make sure that you are doing it in open waters. So again, the state agencies will shut down an area for commercial and recreational shellfish harvesting if any harmful algal blooms are present.
Okay. Also from Martha, wanting to know about HABs in the Panhandle. So your banner kind of covered like from Pensacola over. So, and I know that they're there, but so if you will speak briefly on that.
Let me try and navigate back to that picture. Are you seeing it?
Yeah.
Okay. So you do have Krimsky brevis red tide in the Panhandle. You do have rare occurrences of cyanobacteria. Most freshwaters in the state of Florida do. I would say the primary one that you have is this diatom that's called Pseudonychia. That's the one that has shut down shellfish harvesting areas in, I believe, St. Joe Bay in the Panhandle. It's only happened, I think, maybe 2 or 3 times. So, but you do have harmful algal blooms, every place in the state does, but they're not regular occurrences by any means. It's kind of an event when they happen in the Panhandle.
Okay, another question is based on all the different departments, like FWC and Florida Department of Environmental Protection, is there a hierarchy of control that either helps or hinders the control? In other words, are they in sync with control, or are there issues or, you know, tension there?
Yeah, no, they are in sync and they actually coordinate really closely. So again, FWC does the marine HABs. So if it's saltwater, it's FWC, whereas DEP does the freshwater, the cyanobacteria. And then they both partner with the Department of Health, who is responsible for disseminating out the toxin information for public health advisories. So those caution signs that you might see near a water body that says caution, cyanobacteria is present in this water body, that's the Department of Health putting a caution sign based off of data that was collected from either FWC or DEP. So they really do coordinate very closely. And with that protectingfloridatogether.gov website, they're really trying to streamline that even more.
Okay. The question from the same Master Gardener, are there practical mechanical methods of prevention or control of HABs? So thinking about ponds and streams or other large bodies of water.
Yeah, control is probably an easier one to get at than prevention. And it depends on the size of the water body. So smaller water bodies, a lot of times you see fountains and aeration in like stormwater ponds or large lakes. That's turbulence, that's water moving. So that's going to prevent the accumulation of a potential bloom from occurring. So that it looks pretty, but it's also a prevention strategy. There are ways to sort of collect some blooms, especially the macroalgae blooms, but it's always dependent on the size of the water body. And so Krimsky brevis, the red tide, impacts the entire Gulf of Mexico. Although there is research on control strategies right now, just in terms of the large geographic scale that we're looking at, nothing's really been successful, but there absolutely is in smaller water bodies. And I think it was Sarasota County, Abby Turner, who's one of our water resource extension agents in Sarasota County, and Dale Laughinghouse, who is one of our algae specialists at UF IFAS, just put out a fantastic sort of 4-page sort of, so you have a cyano bloom in your stormwater pond, what do you do about it? How to control it? So, and it goes through a number of the control options if you have a bloom. And I can share that with Wendy for dissemination.
Okay, that would be great. Cindy Dwyer wants to know, what is the relationship between HABs in Lake Okeechobee, the Gulf Coast, and Biscayne Bay? How is that all kind of tied together?
So Biscayne Bay is not connected to Lake Okeechobee or the Gulf of Mexico at all. So the HABs that are occurring in Biscayne Bay are uniquely its own. Occasionally, the cyanobacteria blooms that have impacted the coastal estuaries, the Caloosahatchee and the St. Lucie estuaries on the west and the east coast respectively, have occurred in years where there have been large freshwater discharges from Lake Okeechobee. And cyanobacteria blooms in the lake have been discharged out the canals and thus have occurred in those estuaries. So there is a direct link to those. Again, red tide in the Gulf of Mexico is unique in and of itself. It's one of those natural blooms that it's going to occur no matter what. There is research going on right now. Again, remember I said it's natural, but it may be exacerbated by human nutrients. So there's research going on right now to see whether or not Karenia brevis growth will increase or has increased due to some of the Lake Okeechobee releases or even the cyanobacteria blooms, because algae themselves are a source of nutrients, and whether or not that can fuel red tide once it's in the nearshore environment. So that's research that's ongoing and active right now, but has not been conclusively linked yet.
Okay. Somebody wanted to know a little bit of the breakdown of who you surveyed again.
Oh, okay.
Demographic breakdown.
Yeah, so it was the IFAS faculty, you know, all of us extension agents, there's approximately 400 of us. We all have advisory committee members. So these are individuals in the local communities who provide guidance to our extension faculty and what programs they should work on. And they are members of the local community. So I reached out and surveyed approximately 1,200 members of the Extension Faculty Advisory Committee members. So they are not representative of, again, the general Florida public, and they tend to represent sectors that we in Extension work with. So agriculture, horticulture were our two primary affiliations, so to speak. Then we had 4-H, family and consumer sciences, natural resources, and Sea Grant, and a handful of others. But those were the primaries, and agriculture and horticulture were definitely those that we had primary feedback from.
Okay. I'm going to ask you an easy question, then I'm going to ask you a hard question. So
Okay.
the easy one is, what do they want? What do you all want us to do with pet waste?
Don't leave it on your yard, essentially. Not only is it a source of nutrients, it's actually a huge source of bacteria. And so from a human health perspective, so pick it up, bag it, throw it in your garbage. If you're really committed, you can flush it down the toilet. Just dispose of it in any way that makes it comfortable for you.
Okay, so this person often buries it.
Because it could still leach into and then enter the groundwater as a source of nutrients and bacteria. So we don't want that.
Okay, so that was the easy question.
Okay. Oh, okay.
The hard question is 30% of nitrogen coming from atmospheric sources. Could you just dive into that a little bit? And it's when I have to tell you all, Master Gardeners, when I first saw the reports on that, I was just gobsmacked. I was like, what, how is that even possible? How is that happening? And so Lisa, I'm gonna ask you to do your best.
Yeah, so, and you can see, I know this picture is a little confusing, but on the left-hand side here, if you look at the right number versus the right-hand picture, the right number. So that's dry season versus wet season. So atmospheric deposition comes from rain and lightning. Essentially, lightning itself will produce nitrogen. Our atmosphere is made of nitrogen, but there's also contributing industrial sources, car emissions. Those are all sources of nitrogen that get trapped in the atmosphere and return back down in rain. So our rain itself is actually pretty nitrogen rich, which is one of the reasons why a lot of people, and master gardeners included, say if your plants are doing a good job in and of themselves, there's no need to supplement fertilizer. It's because the rain and the soils in and of themselves have a lot of nitrogen, and you may not need that extra application. I don't know if that answered the question.
I think it's good.
Okay.
I think it's good. Somebody, and I can't find it again because I saw this. Is there any regulation on our big companies and their fertilization? So, I mean, you know, we have our voluntary programs too, and then we also have legislative fertilizer regulations in our local levels, but these big companies, ag companies, are there any regulations for them?
So there not regulations in terms of what can be applied, but are, you know, the green industries don't have regulations in what can be applied either. They have to take the green industry's best management practice and get a license, but there's no, you can only apply X amount of fertilizer. It's guidelines and recommendations. And agriculture has the same thing. They have the agricultural best management practices, and how much fertilizer can be applied is going to be dependent on commodity and crops and where they are in the state.
Okay.
But yeah, they sort of have that same best management practices guidelines as the green industries do.
All right. And another question about horse and cow waste, you know, and there's a lot of residential horse and cow owners as well. So
yeah, that is a huge opportunity for improvement. I am not intimately familiar with it, but I do know there are couple extension faculty are really trying to spend quite a bit of time on sort of small farm urban horse manure, and I have heard some nightmare stories of just sort of residential horse farms piling up manure on the side of the road and just kind of hoping
right,
it'll take care of itself. So I think that is a huge area for opportunity. I also don't think the impacts have been quantified well enough to really see how significant it is or is not.
Okay. And then would aerators be beneficial or detrimental in managing algal blooms in small freshwater ponds?
For the most part, it would be beneficial. The only time it would really be detrimental is if you have an algae bloom already. And the aeration could break apart the algae cells and release, if there are toxins, it could potentially release those toxins. But so I would turn off aeration if you have an active bloom, but if you just have sort of a stormwater pond and want to keep it going and try and prevent the growth, aeration is really successful.
Okay. And then talking about native soil in Miami-Dade County consists mostly of rock and or sand. Does it still contain a large amount of nitrogen, or is that more true on different areas? And you know, I'm from there. And in fact,
I was going to say, it's not something I can respond
this is my soil sample from the farm I grew up on, which is a Miami oolite rock here. But the marl that's within that rock gets broken up. And actually, that's a pretty good soil type that holds on to nutrients. It does have a good cation exchange capacity. So it kind of, but it's different. It would totally depend.
Yeah, and I think also because it's limestone, it really it attracts phosphorus really well. So I think it kind of binds the phosphorus too. In terms of nitrogen, I don't know as much.
Well, I guess we're getting to the point. There are great questions, and but someone has asked for you to talk a little bit about the Water Ambassador Program.
Okay. So I, myself and Vincent Encomio, who's the Sea Grant agent in Martin and St. Lucie counties, we do an education program on stormwater with Martin County. We're contracted with them as part of their pollution discharge permitting. to do education to Martin County residents and stormwater and water quality issues, and really encourage different opportunities and ways for them to reduce their nutrient inputs. So it used to be a workshop series. With COVID, we've transitioned to a webinar series, and those are open to anyone. So it's not just Martin County. And it's great. While we do keep it semi-regional, we've had some fantastic presentations.
Lisa, in the future, if you would send those to me, and then we can get them up on the Master Gardener calendar, especially the virtual ones, and then they can tune in, that would be great.
Yeah, and they're always, they're Tuesdays at lunchtime. So
Nice.
It's not every Tuesday, but.
Okay, I'd like to get those on our big calendar.
That would be great.
And then I think we're going to do one more question, and it was you showed the copper being used to knock down algae in one of the ponds. I'll let you zip to it. And they want to know what, copper in the water, what's the ultimate environmental effect of that? Is that a problem,
It can be, and it's not widely recommended for natural lakes. It does a great job of killing the algae, copper sulfate. It can have some impacts, especially on sort of the invertebrates in the sediments and stuff. I am not the expert on that. I would definitely, Dale Laughinghouse, again, he's our state specialist on algae. His primary research area is controlling of cyanobacteria blooms through sort of these different control methods and evaluating the impacts and success of them. So I would suggest reaching out to him on those questions to get details.
Okay, and so what I would suggest for that Master Gardener is to contact your extension agent and propose these questions, and then maybe the two of you together contact Dr. Laughinghouse, and maybe even he would come and do a local program for you or answer those questions directly.
Yeah, or that answer might actually be in that 4-page document that I talked about as well. So I would read that first and then reach out and see if you have any additional questions.
All right, for those of you who are still with us, remember that this webinar has been recorded, and it will be posted on the Master Gardener website along with Lisa's slides, so you can refer to that in the future. And Lisa, let me take the opportunity to thank you for presenting to the Master Gardener volunteers. We appreciate you appreciating us and understanding us. Not all of our speakers understand the passions and the knowledge and the education of the Master Gardener, so we really, really appreciate that. And for those of you taking the Qualtrics quiz on the back end, those data will be shared with Lisa. She can put that in a report retroactively. Nicole Pinson said, thank you very much. And she would love to see the data that you collected off the Mentamere, and maybe just contact her back and share that with her. So that would be great. So I really appreciate all of you tuning in and your excellent questions. And Lisa, happy holidays, and thanks for being with us today.
Thank you, you too. And I put my contact information up again, just in case anyone wants to shoot me an email. I'm happy to respond to any last minute questions, but thanks for the invitation. I really enjoyed this.
Yes, we enjoyed it too. Thank you.